Hi, everyone. Welcome. Welcome to our session. Thanks for joining us. I'm Phil Dworsky from SiFive. I'm head of strategic alliances. And I'm pleased to host our panel today. It takes a village to build an ecosystem. We tried to have a pithy title anyway. Thanks for joining again. We heard in the last session about a development system. There's a lot of development system type activity going on. If you go on the show floor, you see a lot of great activity in RISC-V, doing well. We're really actually at an inflection point today, being adopted widely by leading semis across all kinds of different applications. And similarly, the ecosystem is expanding rapidly. And in fact, some would say that the future of RISC-V, the ecosystem, is actually a promising and is seen as an advantage for many. Rather than try to go into depth with each of our panelists' incredible accomplishments, I'm just going to introduce them, and you can look up their biographies later. I'm sorry, we have a 20-minute panel. So we have a really incredible panel here. We're joined by Amber Huffman, who's principal engineer at Google Cloud. Bob Brennan, who's VP and GM, Customer Solutions Engineering at Intel Foundry Services. Dan Mender is VP Business Development for Green Hills Software. Pete Lewin is Director of CPU Ecosystems at Imagination Technologies. And Rob Aitken is a Distinguished Architect at Synopsys. So welcome all of you, and thank you for being here. Really appreciate it.
Thanks, Phil.
Okay, so we've got a few questions to get things rolling here, and if we have time later, we'll try to entertain questions from the audience, but I just don't know if we're going to be able to do that or not. We'll see how it goes. What I'd like to do is open with a question that I can ask for all of the panelists. And given how things look rosy, but there are still a lot of things left to do, what I'd like to ask of each of you is what's a key challenge facing the community today? And what are your companies or your segments doing to bring, what's a key challenge facing the community to achieve the breadth of RISC-V adoption we're all wanting to see, but how would you go about addressing that challenge for each of you? So Amber, why don't you go ahead and start there?
So I think that the challenges that Lebout laid out in his keynote slide this morning resonated, and so just touching on two of them that are especially resonating with me are the software ecosystem, and the second is the making sure that we don't fragment. And so I feel like that's one of the key things why Google is present here is how do we, in open ecosystems, really address coming together to do coherent of filling the gaps in the software ecosystem together and making sure that we address that. And then the second piece is making sure that how do we come together that when RISC-V and you land software on something that's RISC-V, it just works. And so that's going to be really key for our industry.
Okay, Bob?
Well, as usual, Amber said exactly what I was going to say more intelligently. Thank you, Amber. I feel like we're at Intel in 1995 or 6, somewhere like that. I feel like the hardware-software ecosystem is in that form. We did a spiral where we had hardware and software growing like that. And we found out that the hardware was not only the ISA, it was also the platform. And so we have to think about the ISA, the platform, everything that goes around it, and then the software that supports it. I think RISC-V International is doing a great job freezing the ISA and profiles. And secondly, I think we have to have equally frozen profiles for Linux and all the development that goes around it, as Amber eloquently said. Next, I think we need money, and that's where Intel is putting in the so-called billion-dollar fund to prime this ecosystem to accelerate the growth.
All right, Dan.
I think I'm the only software person up here. Well, Google, you do a little software, I think, too, right?
They don't let me, though.
So Green Hills software, for people that don't know Green Hills, because I know that a lot of the conference is very hardware-centric. As you were mentioning, it's getting the IP right, getting the architecture right, learning from lessons learned from the past, innovating, making the hardware differentiating and evolutionary versus revolutionary versus evolutionary. So, but from a software perspective, it's how does that help with the next step? So we actually get involved with helping with our lessons learned in 40 years and running on embedded microprocessors. We've got a lot of lessons learned. We understand how to help people that are actually designing hardware from a software perspective. What are you doing from a hardware perspective to make sure things are optimized for performance, for safety, security, the things that are important when you actually start building products, right? When you take this from an idea to actually building products. So we get involved in the very early stages and are helping from that perspective. But the other thing that we bring as a company is a strong portfolio of products, technologies, and know-how on production-ready capabilities. So when you're actually getting ready to build products, having a complete portfolio of development tools, target IP that are operating systems and hypervisor services, and other capabilities that are production-focused, safety and security certified, and ready to be used out of the box on RISC-V. So we're seeing that that's a very important thing that we bring to the RISC-V go forward, go-to-market strategy.
All right, Pete?
And well, it's not going to surprise anyone that I'm going to say software ecosystem is the major challenge I think we've got to address here. It's really that chicken and egg problem, right? Of nobody's going to spend a lot of money porting software and optimizing software until platforms and hardware platforms are widely deployed, but you're not going to widely deploy any platforms until the software ecosystem's in there. So it's that kind of chicken and egg and kickstarting the whole thing. I think we've got to address it by being quite coordinated across the kind of all the companies that are working with RISC-V, because there's tons and tons of expertise in this room. All the expertise is there, all the experience is there, but it's really that unified working together, going in the same direction, and how we actually coordinate that in a better way. Just to make sure that we're not all doing little bits here and there, but it doesn't add up to the whole that it could do.
Good. Rob?
Well, I guess I should say software ecosystem because that's an important. I hear that's important. In addition to that, I think from a Synopsys standpoint, I think the thing that's really a key piece is the implementation part. So having kits that are available that actually target specific RISC-V cores and allow you to, with a combination of a library plus tool flow, et cetera, to really optimize the hardware design. That's at one end of the spectrum. And then we also provide tools on the other end of the spectrum which can say, here, take an executable, optimize that. Let's tune this specific workload, the inner loop precisely, so that we really speed it up on a given processor system. So everywhere from one end to the other, there's an opportunity to work together. And I think the real key thing from the ecosystem perspective is exactly what we started with Amber and with Lip-Bu's talk this morning. It's how do you make sure that you enable all the diversity that the RISC-V ISA lets you enable, but at the same time have enough standardization that the tool ecosystem and the software ecosystem exist.
I think the biggest step function we saw in the growth and the birth of the RISC-V ecosystem was the introduction of development systems. I think, Pete, you touched on that as well, that having that hardware platform to start developing, and that begets software, which begets the next platform, I think is a huge step. Yeah. I'd like to give you an opportunity to amplify, if any of you would like to, on the topic here being it takes a village. The notion is we've got an eclection of people and companies represented here. So in terms of what is your specific company bringing, or your market segment bringing to the puzzle. Rob, do you want to start with that?
Sure, I can elaborate a little bit on the idea of these implementation kits for ARM and for ARC, for example, at Synopsys. There are very optimized flows for specific processors, and those are now starting to be developed with SiFive and others to make sure that there's an equivalent path for a given core, because it's really not it's not an instantaneous thing that you say this core can achieve X megahertz or X gigahertz. It takes a village, and it takes a bunch of tools, and it takes a methodology, flow, and library to make that go. So that's a specific piece that Synopsys brings.
Pete, did you want to?
So Imagination, we bring 20 years of expertise in developing compute IP, deploying that compute IP, and importantly, supporting our customers to get the best out of that compute IP. That's got a history in CPU as well. So there's that experience, and as you say, there's a whole village of different tools, different expertise, different disciplines that go into deploying a piece of IP in particular, and it's that kind of heritage and experience of bringing that up that I think we really bring. And then in addition to that, of course, there's the heterogeneous compute idea, because we've got the graphics processing, we've got the artificial intelligence accelerators as well, and so that kind of, it's not just a CPU, it's that whole, how do you work that across the whole heterogeneous compute solution?
Okay. Dan, would you like to add?
Sure. As a software company, we, as I mentioned, we've been in business for 40 years, and we actually bring 4 different business segments to the RISC-V ecosystem. We actually started developing for RISC-V back in 2018 with one of our business segments. So we have a standalone compiler business segment that focuses on the highest performant optimizing CNC+ compilers for production code that's both safety and security certified, up to ASIL D and SIL 3, SIL 4 for RISC-V today. So the tools themselves and the runtime libraries for CNC++ are available for RISC-V today. We have development tools that, as these brilliant people that are building all these amazing, complex, high-performance processor architectures, they're on top of that's going to be some very complex software solutions. So you need some very sophisticated ways that you can debug beyond using something like printf to be able to understand what's happening in these systems that are multi-core, multi-OS, multi-function, mixed criticality. How do you debug that? So we have advanced development tools for that. I think another standalone business of ours. And then we also have target IP that ranges from the small microcontroller, real-time cores as they're called, and then also the application cores. So we have safety certified real-time operating systems that span the microcontroller to the application processors, and hypervisor solutions from the microcontroller to the application processor. So we bring a unique breadth of mature production-ready solutions to the RISC-V portfolio that help customers with, really bridging that gap of, hey, I'm kind of doing some prototyping, I'm doing some R&D, and now I want to move to production. So without having to basically replace wholesale the whole R&D thing that I did on some non-production ready software, I can start with production ready software today, even at the point where I can start using models from Synopsys. I can start doing things from a model perspective even before I get to the target hardware.
My old boss used to say it's an electro-political decision which tools to use. Think over that for a minute. But the ability to be able to drop in and move from another architecture to RISC-V and not have to give up the tools that you hold so dear, I think is a good observation there. Oh.
Well, I apologize. I didn't bring my Intel Foundry marketing slide set today. So 3 things: money, silicon, open source software. Okay, money is the $1 billion fund. We're hoping to seed the ecosystem. We're hoping to raise all boats. Of course, we'd like if the boats would land on Intel Foundry silicon, but not necessarily. Second is silicon. The talk prior to this one and this morning demonstrated the SiFive P550 silicon development board. We hope that propagates. We hope that gets in the hand of a lot of developers. I hope that becomes like the Raspberry Pi of RISC-V. Third is open source software. We're working with Amber, Mark Scarpness at Intel, and a group of interested folks together, and we plan to allocate resources. We have some experience with open source. In fact, at one point, Intel was one of the biggest open source contributors in the world, and we hope to bring that expertise to bear to fill in the gaps for silicon. So again, money, silicon, and open source.
Cool.
Great job by the team that did Horse Creek. So from a Google perspective, we believe in open ecosystems. And so if you look at open source software, if you look at Kubernetes, if you look at Chrome, if you look at Android, and we're very excited that Android is now accepting RISC-V patches. So we just see that open software ecosystem is something that over time, RISC-V, we're excited to see how RISC-V plays with that software ecosystem. And then what I'm very excited about is the open hardware ecosystem. So as we look at, for example, the root of trust solution that we announced at Open Compute Project along with NVIDIA, AMD, and Microsoft called Calyptra, it has a RISC-V core at the source of it. We're taking that through CHIPS Alliance. And how do we develop open source hardware together and really have security that all of us are auditing the same RTL, working together, and that, of course, supplements also OpenTitan that also uses a RISC-V core. So it's a pretty exciting time.
I want to follow that up. The announcement that upstreaming for RISC-V in AOSP is probably an earth-shaking thing for many of us here, but can you explain what that means? Where are we today and what's next in terms of getting Android support up and running there?
Yeah, so in terms of the Android open source project, I would encourage all of you tomorrow to join the keynote that Lars Bergström is going to give, who is the person leading the effort with the Android open source project with accepting RISC-V patches. But channeling my inner Lars, it's initial days. So now we're receiving RISC-V patches, and it is going to take time to develop the full support there. And that will come with, we need to have really get to, over the next year or whatever time it takes, Tier 1 quality and reliability. There's also some platform features for performance and security that we're excited to see mature. And so there's more baking to do that we're excited to now do with the community, because now that it's accepting patches, now we can all mature that together and then see what future products people imagine. So I'd encourage people to check out Lars's talk tomorrow.
It's very pragmatic, but I think exciting at the same time. I think all of us are pretty excited about that. As we're starting to see RISC-V reach into many different markets, automotive is one that's popped up recently. So I'd like to understand, Pete, maybe you can comment, what's really required for RISC-V success? Are there any barriers in the automotive space?
So it's a difficult problem. And it's a difficult problem because there's a massive wealth of software already existing. So it's a huge ecosystem problem to start with. But there's also now so much evolution in the automotive market. So much is developing. So much is now more complex, more software, and yet still has to stick within power budgets and those kind of things, that you're really targeting a moving target. And if we kind of draw up all the software support we feel we need today, by the time we've reached that, it's not going to be a patch on what we need everywhere. So we've got to target that, what new software do we want, when will we want it, and getting all of that in place is really going to take massive amounts of coordination. I think that's possible. I hope that's possible. We're running the Automotive Special Interest Group in order to try and pull together all of that expertise that we've got across the whole RISC-V ecosystem to work out not just what we need today, but what we'll need in the future. But yeah, that's still a barrier. You can't sit back. We've really got to drive that quickly. And then the other balance really is that there's a lot of drive for standardization so that we don't do the same thing time and time again. You do it once and we can use it across the whole industry. But at the same time, because of this rapid evolution, there's lots and lots of innovation happening in the automotive industry, lots and lots of diversity, problems being approached, particularly around ADAS and automated vehicles that really are just going to be different approaches, different places, and you don't want that standardization to stifle the innovation. And it's getting the balance between those two.
I think we were grateful when we announced our automotive portfolio of the rapid adoption of the ecosystem coming on board and support. So, why reinvent the wheel? There's a lot of automotive support already out there. Now they're bringing that to the RISC-V architecture, so I can see that for sure. Bob, special question for you. I've seen you speak on this topic before in understanding where RISC-V plays in the overall processor ecosystem. And some would say that the ecosystems of the other architectures is a barrier, right? It's a barrier to, how can you compete with that? And wanted to get your take on where RISC-V sits in that kind of respect.
So what you're really asking me is when will RISC-V replace x86? Is that what you're asking?
There it is. There it is.
And my response to that is going to be that by 2030, we want to be the #2 foundry in this world. We believe that semiconductors are growing at a 5% CAGR. It's $1 trillion market in 2030. And if we want to keep all those gorgeous fabs, expensive fabs full, the only way we can do it is by embracing x86, ARM, and RISC-V. So that's what we call multi-ISA strategy. And we're excited to see the growth of RISC-V in the emerging markets. And we're excited to see everybody here contributing to the growth of that ecosystem.
A lot of opportunity, right?
A lot of opportunity for all of us.
Yeah.
Yep.
Okay. So this isn't the first time ecosystems have been built around the CPUs, right? There's been plenty of other opportunities before. What can we learn from the previous times around that we're going to get right here in RISC-V? Does anybody want to take a lead on that one?
I will. I think what to learn is ecosystem development is pretty slow, or can be pretty slow. But there's really a huge momentum effect behind it as well, right? So you have to celebrate all the little wins. Every little thing might not seem very significant on the kind of scope of everywhere you've got to get to, but every little win helps. Everything builds that momentum, gets things moving. And I've always found that you suddenly realize in an area that the support is there that you didn't really realize was. So it's kind of not getting disheartened by the size of the task, the amount of work that goes in there, but at the same time trying to learn from previous ecosystem developments. Got to realize RISC-V is in a different position. Most ecosystems have built up in a given segment, and they've become quite mature in that segment, and then they're going to grow into adjacent segments and then fill everything else up. RISC-V is kind of taking it all on at once. Which again is great. It lets you really benefit from those synergies, but it does take a lot of coordination to do that.
Yeah. So I hear lots of opportunity. We've seen it done before. We know where we're going. We seem to be on a good path, and we seem to have a good idea of where we need to go together as an ecosystem. I think that's a great way to be able to wrap up. We've got no time left for those who are viewing on the broadcast. So. Goodbye to you. Thank you so much. And thanks to the panelists very much for joining us and speed dating on this panel. Thanks very much.
All right.